So this is Algebra 2 with trig. Review for quiz 6163. This is the first worksheet, 6-1. We have rewrite as rational exponent. The 3 is going to be the denominator of your fractional exponent. You have a radical. The index is your denominator, and now it's in rational exponent form. Rewrite using radical notation. We have 33 to the 2/3. So that's the cubed root, because the denominator is the index. You have 33. Now you can put the 3 above the 33, or you can put the square. Put the square above the 33, or you can put the square outside the radical. Either method would be right. We have 9 to the 5/3. That is the cubed root of 9 to the 5th. That can be broken down, but since we're just rewriting it using radical notation, we can leave it like that. Is that a little blurry? Sorry about that. Evaluate the expression without a calculator. So we take number 13, and that's the cubed root of 8 quantity squared. The cubed root of 8 we need to know is the value of 2, because 2 times 2 times 2 makes 8. Square that, which gives us 4. Number 14 is the 4th root of 16, and that's supposed to be cubed. So the 4th root of 16, 2 times 2 times 2 times 2 makes 16. So to evaluate it, that comes out to be 8. 15, 4th root of 81 to the 4th power. The 4th root of 81 is 3 to the 4th power, which is again 81. So if you're taking a radical with an index the same as the power, you're going to get what's inside. "17, it's 4 to the 5/2. We're doing the square root of 4 to the 5th power. That's 2 to the 5th power. That should be the number 32. Number 18, 27 to the 2/3. That is the cubed root of 27 squared. Well, the cubed root of 27, 3 times 3 times 3 makes 27. So the cubed root of 27 is 3. Number 20, negative 8 to the 1/3. It's okay to take the cubed root, which is an odd index, of a negative number. Same thing with negative 32 to the 3/5. It's the 5th root, negative 32 cubed. So 2 times 2 times 2 times 2 times 2 is negative 32 cubed. Negative 8. So we're going to solve number 33, 2x to the 5th plus 73 equals 53 by subtracting across. You get negative 20. By dividing across, you get negative 10. And you can do the 5th root of negative 10. At this point, I'm not too concerned about what that exact decimal is. 34. This is the interesting one. You have to take the 4th root of that amount, and you'd have to take the 4th root of that amount. So the 4th root of something to the 4th power leaves you with a plus or minus. I think this is 3.67. It doesn't come out evenly. Okay, not quite that. 4.36. So we're going to have to break this apart into x plus 3 equals 4.36 and x plus 3 equals negative 4.36. You got to notice that when you take the cubed root, which is an even index, the 4th root of that is plus or minus. So we subtract the 3 to get 1.36, or we subtract 3 to get negative 7.36. So for the 6.2b, number 1, we're multiplying the same base, so we're going to add exponents. We got to have the same denominator to add those fractions, so we get 5/3. The the bases have to be exactly the same, and you're multiplying two bases together. So we're supposed to simplify. Theoretically, if you wanted to work this out more, you would have at least 3 of them in there, with 2 left over. So you can call that 49, you can leave it at 7 squared. Number 2, this is 4 2/3 over 4 1/3. Again, you have the bases the same, so you're going to subtract to get 4 1/3. Since the questions are starting in fractional exponents, I'd suggest to leave it in fractional exponents. Either way would work. Number 3, 6 2/3 raised to 3/4. If you raise in a power to the power, you multiply. So you get 6/12, which is 1/2, which is the square root of 6. Number 4 is 5 to the 1/4 times 3 to the 1/4. Now notice how this one does not have common bases. So the only thing we can do, you can call it like factoring out your 1/4, which leaves you 15 to the 1/4, which you could put that into a radical if you want and say the 4th root of 15. Okay, here, because both of our indexes are the same, they're both 4, you're allowed to multiply your 2 and the 8 together to get 16. 2 times 2 times 2 times 2, there's 4 of them, that makes 16. Number 7. This is a tricky one. Here, there's nothing we can really do with that. But we know that it's incorrect to leave a radical in the denominator. So I currently have 1 of the 11s down there. I need to have 3 more 11s to get my total number of 11s up to 4. Whatever I do to the bottom, I also have to do to the top, because now I'm multiplying by a value of 1. So that gives me 11. The 4th root of 11 cubed over the 4th root of 11 to the 4th. Now I have 4 11s down there. And that's going to give me 11 on the bottom. And that can cross out with my 11 on top and give me the 4th root of 11 cubed. Look back that the 4th root of 11 to the 4th, there's 4 11s in here. So if these two numbers are matching, it's like saying the same thing as 11 4 over 4, which is 11 to the 1st power. They match. They cross each other out, essentially. And then we reduce from the top to only get what we started. If you want to type in your calculator 11 times 11 times 11 and put that number in there, you're welcome to do it. Number 9. The 3 raised to 3 over 2 times 2, or raised to the 2. So that's 3 6 over 2, which is 3 to the 3rd, which is 27. Number 10, 54 over 64, the cubed root of that. Well, I can't really reduce 54 and 64. Maybe I could take a factor of 2 out of there or something. But if I leave it as the cubed root of 54 over 64, and I split those up into 2 different pieces, I know that the cubed root of 64 is what? 4. What's 54? I gotta check this out. 54 is 9 times 6. That's 54. 9 is made up of 3 times 3. 6 is made up of 3 times 2. So there's actually another perfect cube inside of that. So my final answer perhaps would be 3 cubed root of 2, because it would have been 3 times 3 times 3 inside of there to be 27 times 2 to be 54. I'm going to pull out the cubed root of 27 and have my 4 on bottom. That was a tricky one to see. Number 11. We got the 4th root of 32 and the 4th root of 2, because they both have the same index, and it looks like it's going to be helpful. It's not always helpful, but it looks like it's going to be helpful. The 4th root of 32 over 2, which is the 4th root of 16, because that comes out to be 2. Sometimes that doesn't reduce, and it doesn't really help to combine it like that. You got to try something different, like number 12. number 12 is the fifth root of 5 over the fifth root of 27. Alright, so we have the fifth root of 5. It wouldn't help to break this into 5 over 27, but if it's quick to see that 27 is made out of 3 cubed. 3 cubed is 27. The problem here is that we have a radical in the denominator. We don't want a radical in the denominator. So I need to do what's called rationalize the denominator. I need to get 5 of those 3's down there. It would be okay to work with the 27's. You could do 4 more 27's, but that would require reducing at the end. So if you notice you can reduce your number and deal with smaller numbers, that's going to be better for you. So here we have 5's that are the same. So I have 9 times 5, which is 45. I have the fifth root of 45 over 3. Because that's 3 to the fifth inside the fifth root, which comes out to be just a 3. Number 13, we're still simplifying, but now we're going to work with variables. So we have x to the 5/3 times x to the 4/3. Your bases are the same, so you are going to add exponents, because we're multiplying. Only when we're multiplying do you add exponents. So you have 9/3, which is x cubed. Number 16, x to the 7/5 over x. No, I'm doing number 19. X squared over 27, and this is to the 1/3. So one thing you can do is turn this into, you can distribute that through to say x to the 2/3 over 27 to the 1/3. Fractional exponent here tells you that the denominator is going to be a 3, because 3 times 3 times 3 makes 27. This is the cube root of 27. And this is x to the 2/3. There's nothing else you can do to that. Number 17, which is the cube root of 16, x to the 4th. Well, 16 is to the 4th. That's x to the 4th. So I'm going to get a 2x to come out of it. And I'm still going to leave a 2x on the inside, because I have 4 2's. 2 times 2 times 2 times 2 on the inside. I'm going to circle 3 of those and bring it out. So I'm going to have 1 left, and the same thing with the x's. Number 19, x to the 7/5, x to the 4/5. The bases are the same. 7/5 minus 4/5 equals 3/5. Because it started with fractional exponents, you can leave it with fractional exponents. You know that it can't be reduced if the top number is smaller than the bottom number. Number 20. Cube root of 64, x cubed y, 4x to the -3 y. Well, the cubed root of 64 is 4. The cubed root of x cubed is x. And I'm left with the cubed root of y. And then I have a 4 down here. I'm going to bring my other x up to the top. to make it a positive exponent, and I have a y in the bottom. Okay, so my 4's are going to cross out. I'm going to get x to the 4th. Now notice how I have y's on top and on bottom. So this is really y to the 1/3. And you subtract it with what you've got on the bottom. Which is a value of 1, which is 3/3. This is going to get messy. So this is going to be x to the 4th, y to the negative 2/3. I'm going to turn right back around and do the same thing because I'm going to have to rationalize the denominator. I'm going to need one more y to get 3/y, so that's actually going to be my best answer. So x cubed root of y over y. I tried to combine the y's, but that was going to force me into having a fractional exponent in the denominator, which needs to be rationalized. So this answer, which is x there, this should be a 4. The exponent on the x needs to be a 4. X cubed and x, 1 plus 3 gives you 4 of those x's. The cubed root of y over y. So this wasn't actually needed, and neither was that. We have x to the square root of 2 raised to 3 square root of 2. So what do we do when we have a power raised to the power? We multiply. So square root of 2 times 3 square root of 2 gives you 3 times 2, which is x to the 6th power. Number 24, cubed root of x to the 4th times the square root of x to the 5th power all with a negative 2 in front. Notice how the index is different. So if the index is different, let's put this into a fractional exponent. And now you have the bases the same, so you can add 4/3 plus 1/5 together, which is going to give me 15 for the denominator, a 20 for the numerator, and a 3 for that one. Which is x to the 23rd 15th. With a negative 2 on the outside. So you might call this 1 over x, and when we square this, that's multiplying to get 46 over 15. Now 46 over 15, 15 goes into that 3 times, so there's 3 groups of x's that can come out of that, with 1/15 left inside. And we would have to rationalize our denominator. We need 16 more of those. This is looking pretty ugly. We need 14 more of those. We do 14 more, so I'm going to do the 15 to the 14th, the 15th root of x to the 14th, and that's going to give me 15x to the 14th on top. It's going to be x cubed on bottom with 15 x's on bottom, so that's another x. So this is 15th root of x to the 14th over x to the 4th. Wow. And that whole time I was off the screen. So here the negative 2 was multiplied to the 23 to get 46. I put it on bottom already because it's negative. 15 goes into 46 3 times, so I brought x cubed out, and that left me with one remainder that was still inside. So I rationalized the denominator by needing 14 more to get up to my 15. I did that to the top and the bottom. So the 15th root of x to the 14th gives me a numerator. I need 14 more, which gives me x to the 15th, which gives me just x, and that adds together to get x to the 4th. So for number 25, we have 6 cubed root of 5 plus 2 cubed root of 5. Because the cubed root of 5s are exactly the same, this is just 6 plus 2, which is 8 cubed root of 5. It's essentially saying 6x plus 2x is 8x. Our x in this case is cubed root of 5. Number 26, 5 times square root of 5 minus the square root of 9. Nine times 5 makes 45. The square root of 9 is 3 with the 5 still inside. Now what's inside my square roots are exactly the same, so they're called like radicals. So 5 minus 3 gives us 2 square root 5. Number 27. Two square root 27 minus 3 square root 48. Well, 27 is 9 times 3. 48 is 16 times 3. Square root of 9 is 3. Square root of 16 is 4. So I have 6 minus 12 gives us negative 6 square root 3. Notice the negative is not inside the radical, so that's okay. Number 28, got 2 square root x plus 7 square root x gives us 9 square root x. Because the x is not in a denominator, it's okay to leave it like that. (31) We're supposed to put this in simplest form. We have the 4th root of 3. We have an x cubed, we have an x cubed, and an x. Oh, we're not doing cubes, are we? We're doing the 4th root. So we need 4 of a kind, and then we have 3 of a kind. So there's nothing you can do with the 3. We're going to bring an x out because we have 4 of them. We're going to bring in a y out twice because there's 2 sets of 4 in there. So this is the 4th root of 3x cubed yz cubed. 33. Last one for this page. Cube root of 81 x squared y cubed 8 x y to the 4th z. So I'd suggest to break this into 2. These are cube roots. Don't forget your index. That's a major mistake. So 81 is broken down by 3 times 3 times 3 times 3. So I'm going to have a 3 that comes out. I'm going to have a y that comes out. But I'm still going to have another 3 inside with my x squared. The cube root of 8 is 2. I'm going to have my y come out. But I'm going to be left with an x inside, a y, and still a z inside. Now, that's a cube root also. Now, you're not supposed to have a radical in the denominator. So we have 3y cube root of 3x squared over 2y, I think those y's will be able to cross out here, with the cube root of xyz. I wish I had 3 xyz's, x cubed, y cubed, and z cubed, if I could pull them out. So how many more do I need? I need an x squared more, I need a y squared more, and I need a z squared more to the top and the bottom. So that's going to leave me with 3 times the cube root of 3 x to the 4th, because I have x and x, 2 and 2 make 4, with the y squared, z squared. And yes, we're going to be able to pull an x out. On bottom, I have a 2 with the cubed root of x cubed, y cubed, z cubed, because 2 and 1 makes a cube. I can pull, now since I have x to the 4th up there, I can pull another x out to leave me with a 3 inside, x, y squared, z squared, with 2x, y, z. Well, again, the x's can cross out. And my final answer, oh, look at me, I'm running off the paper again. Cube root 3xy squared, z squared, over 2z. Here I had 2 xyz. I crossed the x's out and I had the 2 and the z, but that should have been a 2yz, because there was a y and a z. The x's got crossed out. Here we're going to add f of x and g of x together. So what we're looking at is 7x to the 1/2 minus 2 minus x to the 1/2 positive 4 So that looks like 6 to the x to the 1/2 plus 2. There's nothing we can do with the 6 to the 1/2 and the 2. You cannot call that 8. F of x plus h of x. 7x to the 1/2 minus 2, and a negative 4x to the 1/2 plus 1. Well, we can rewrite that again. So 7 minus 4 is 3x to the 1/2. Negative 2 and a positive 1 is a negative 1. Nothing we can do to group that together any differently. Five h of x minus f of x. H is negative 4x to the 1/2 minus the f function. Don't forget to have parentheses around your f function. So that's going to come out to be negative 11x to the 1/2 plus 3. Number 6. G of x minus h of x. The g function is negative x to the 1/2 plus 4. You've got to have parentheses around your negative because you're subtracting a binomial. To make that a positive 4x to the 1/2 minus 1. So that's a total of 3x to the 1/2 plus 3. So number 9, h of x times g of x. H of x is x to the 1/2 times g of x, which is negative 3x to the 4/3. We're going to have to add exponents. So 1 times negative 3 is negative 3. 1/2 plus 4/3. So common denominators. So we could leave the answer like that. If we were going to put that in a radical form, how many times does 6 go into 11? Goes in there 1 time with the 6th root, with how many left over? 5. This looks fine, but if you really wanted to work on your simplifying, that guy's awesome. Simplify away. Number 10. F of x over g of x. The f function is 4x squared. G function is negative 3x to the 4/3. So that's going to leave me with negative 4/3. But my x is you're going to take 2 minus 4/3. That's a value of 2. And because the 6 minus 4 gives you a 2, that's not reducible. We can leave that. So here with number 13, we're doing f of g of x. So the f function looks like 2 times something plus 3. We got to plug the g function into that. So that's going to give us 6 over x plus 1 plus 3. There's no way to combine the 6 and the 3 together. You could essentially make common denominators, but no need. That is completely fine. Number 14. G of h of x. The g function is 3 times, actually 3 divided, by something plus 1. The h function is x plus 5 divided by 2. This one's going to be a little trickier. For us to actually do something with that, maybe we should say x plus 5 over 2 plus 2 over 2. That's making our common denominators. That's x plus 7 over 2. And then what do we do if we have a fraction in the denominator? We'll multiply by the reciprocal. So this side will get 2 over x plus 7, and those will cross out to become 1. And this will get 2 over x plus 7. That'll get 6 over x plus 7. That was tricky looking. And then our last one, number 16. G of f of x. The g function, again, is 3 times something plus 1. The f function is 2x plus 3. 2x plus 4. Because 3 plus 1 is 4. And we're good. There's nothing we can reduce.